So, from a paper titled Family of Triangles and Related Curves by Anna Sliepcevic and Helena Halas, Konko, I learned of an interesting parametrization for a one-dimensional family of triangles. So this paper is from 2013. This is the name of the journal, Hazu, volume 515, 2013. Imagine that you choose two straight lines, two fixed lines. One of them is horizontal without loss of generality, and the other one is some chosen line, okay? And then you're going to close this triangle by considering a set of lines about another chosen point, fixed point O, right? So you have here a one-dimensional family of lines that pass through O, a pencil, and then you can easily compute the intersections B and C against those two fixed lines you had chosen. Now, what this video is showing is an interesting phenomenon that over this set of lines, the locus of the Symmedian point is an ellipse shown green over here, right? So if I let, for example, these lines rotate freely, you get this ellipse. So that's pretty cool. The fact that this is both an ellipse and it's compact, right? Some other points like the barycenter and circumcenter and orthocenter, which have been investigated in this paper, they sweep hyperbolae. But interestingly, the Symmedian point sweeps a compact ellipse. Now, two things that I've noticed about this ellipse. Number one, that its major axis, irrespective of O, is always parallel to the angular bisector at A, represented here by this dashed red. So if I slide O around, I get a different locus, but notice how its major axis is always parallel to the angular bisector at A. So even if I change this other chosen line here to some other angle, you maintain that parallelism between the major axis and the angular bisector of at vertex A of this variable family of triangles, right? Okay, the other really interesting property is that the eccentricity of the locus, shown here by this epsilon, is also independent of O. So it looks like the eccentricity of these loci only depends on the angle between the two chosen lines. Okay, no matter where I place O in the plane, I get a different locus, all right, but its eccentricity is invariant overall. Okay, that's all I have. See you on the next video, hopefully.